Hi guys, welcome to Magic Math Stat. Today we are solving the second problem from RMO 2017 question. By the way, if you want more RMO solutions, then I will link my playlist in the I button and you will get the link in the description. So go check that out. Now you can see today's problem right on the screen. There is an equation a cube plus a plus 1 cube plus a plus 2 cube up to a plus 6 cube, that sum equals to b to the power 4 plus b plus 1 whole to the power 4. Now you have to show that there is no integer solutions for a and b from this equation. So the problem is a bit tricky, but I encourage you to try to solve it, then come back to this video to understand my approach. Let's get to the solution. When we hear the word integer, we can think of two things: even and odd. And if we can show that the two sides of this equation mismatch in terms of even and odd, then we don't have to do anything more. But the problem is I have already tried this approach and I couldn't get a solution from this. Now I'm gonna clear out this board and start explaining a trick where I got the solution. Okay, so we start with expanding these cubes. You will see that all of this can be written as a general form, which is a plus c whole cube, and the formula we know is a cube plus 3a square c plus 3ac square plus c cube. If you put c equals to 0, you will get the first term, c equals to 1, you will get the second term, c equals to 2, you will get the third term, and you get the idea. So c is changing for all these terms. A is not. That means the terms with a and constants will be same for all of these cubes. Let's start expanding. If you look at this cubic expression, you will see that a cube doesn't have a c involved. So that means all of these 7 terms will have a cube and we get 7a cube. Now look at the second term, which is 3a square c. Now in that term, obviously 3a square is not changing, only the value of c changes from 0 to 6. And since all the terms are positive, that means we have this addition. Okay? The third term is 3ac square. So 3a is not gonna change. Again, c will change. We get 0 square plus 1 square plus 2 square up to 6 square. That's good. Then we have the last term, which is c cube. So for that we'll get 0 cube plus 1 cube plus 2 cube up to 6 cube equals to b to the power 4 plus b plus 1 whole to the power 4. 7a cube comes as it is. Now 3a square, that's fine, but look at this. 0 obviously doesn't have a meaning in addition. Only thing we have is the sum of first 6 natural numbers. And according to the formula, that is 6 times 6 plus 1 divided by 2. Okay. Next is 3a. And we have sum of squares of first 6 natural numbers. According to the formula, that is 6 times 6 plus 1 times 2 times 6 plus 1 divided by 6. Okay. Now we have the sum of cubes of first 6 natural numbers according to the formula, that is 6 times 6 plus 1 divided by 2 whole square. Okay. Write the right hand side as it is. Let's simplify. This gives me 3, 6 and 6 cancels out. This gives me again 3. So if you look at this expression carefully, you will see that every term has 7 as a common factor. How? Obviously, we have 7 for the first term, but for the second term, we have 6 plus 1. For the third term, we have one more 6 plus 1, and for the last term, we have also a 6 plus 1. 7 is a common factor of this side. Let's take it out. Then we have a cube plus, here we get 9a square. Here we get 39a 63. Write the right hand side as it is. Now this step gives us the contradiction we want. How? You remember that we need to find integer solutions for a and b. The left hand side has 7 as a common factor. That means the left hand side is an integer which is divisible by 7. But the problem is the right hand side. This side can never be divisible by 7. Why, you may ask? Obviously, b and b plus 1 both are consecutive terms. So if one is divisible by 7, another is not gonna be divisible by 7. And there is a theorem in number theory. You can see if x is r mod y, that means if you divide x by y, you get remainder r. Then x to the power n will be r to the power n mod y. Well, what is the best case scenario? B or b plus 1, one of them is divisible by 7. Okay, let's take it. Let's say b equals to 7p. Okay, then that gives us p plus 1 equals to 7p plus 1. Now since b is divisible by 7 here, b to the power 4 will also be divisible by 7. So 0 mod 7. But you see, b plus 1 is not divisible by 7. There is a remainder which is 1. So b plus 1 whole to the power 4 will also not be divisible by 7. We will get 1 to the power 4 mod 7. That is nothing but 1 mod 7. Okay, but you can say that why I am taking b equals to 7p. I can take b equals to 7p plus 1, 7p plus 2, up to 7p plus 6. Well, obviously I can. You can try it. You will get the same result. This side will have a remainder when you divide it by 7. So that means this side is not divisible by 7. So we have left hand side which is divisible by 7, right hand side which is not divisible by 7. And that is the exact contradiction we want. And that means we don't have any integer solutions for a and b from this equation. I hope you have learned something new from this video, and if you know a better solution of this problem, then please comment down below. I would love to know new approaches. And if you want me to solve a problem for you, then you can post it on my Twitter page @magicmatchstat, and you can also follow me on Facebook @magicmatchstat. Well, like the video if you feel like it, share the video as much as you can, and subscribe for more interesting videos. Thanks for watching, guys. I will catch you in the next video.